Today we're going to talk about friction. Since we've been learning about forces, we've been talking about friction a lot. Friction happens when an object's moved while touching another object. So the example I drew of this is when you're driving in a car. There's friction in a lot of places. The biggest force of friction is with the tires, okay? Friction will always transfer the energy of motion, that kinetic energy, to thermal energy, and it always works against the moving force. So if the car is driving forward, the friction is pushing it backwards. There are four basic kinds of friction. The first one is rolling friction, and that's the example I talked about with the car. The roller skate, rolling friction along the wheels. The car, rolling friction along the wheels. Anything that's rolling. So if you were to put a bunch of straws underneath something and try and roll it, the straws rolling would be the rolling friction. Sliding friction. This is when you're sliding something. For example, sliding a box across the room, or you're rubbing your hands together. You're sliding them past each other, and you can actually feel the thermal energy created when you do that. Static friction. It's the first initial move. So if static friction, for example, my hands rolling, that first time I move my hands, that first nanosecond of movement is the static friction. That's why if you're ever moving furniture, it's always harder to get the chair or the dresser moving, but once you've gotten it moving, then it goes. That's static friction, that first friction. The last kind is air resistance. And this is air resistance, a picture of it holding the kite up. You feel this air resistance as like wind going by you, and it's just air getting in the way. Air resistance leads to a special phenomena called terminal velocity. Terminal velocity is the fastest speed an object can fall because of air resistance. Parachuters take advantage? Yes, parachuters take advantage of this because the terminal velocity of a falling person is too fast to safely land. Whereas by changing the shape of the person, now you've got the parachute there, you've got to change the shape of what's falling, the terminal velocity of a parachute falling is a lot slower, making it okay. That's basically what this says. A parachute changes the terminal velocity of a person to be a safe rate. And the terminal velocity will depend on the size and shape of an object.